Swayam Prabha. Digital India. Educated India.
Hello, welcome to Introduction to Composites. Today is the 5th day of the second last week. Yesterday we had defined 3 matrices: A matrix, which is the extensional stiffness matrix, B, which is the coupling matrix, and D, which is the bending stiffness matrix. And these 3 matrices connect the force and moment resultants to mid-plane strains and mid-plane curvatures in a composite laminate. Now, next what we will do today is we will discuss these matrices further and see what physical significance these matrices and specifically their individual elements carry. So, overall the relationship which we had developed was there is a n vector and there are moment resultants. So, they are related to this 6 by 6 matrix, which is made up of A, B and D submatrices times mid-plane strains and mid-plane curvatures. So, these are 6 equations. These are 6 equations. And the element, so we will consider each matrix term individually. So, first we will look at Aij, which is the Ij element of A matrix. This was defined as Qij for the kth layer times Hk, which is the coordinate of the bottom portion of that layer, minus Hk minus 1, and we do this integral or summation from first layer to all the n layers. Okay. Now, this is, let us say, the kth layer, and this is my mid plane. So, mid plane z is equal to 0. So, here z equals h k and this is z equals h k minus 1. So, this difference is nothing but the thickness of kth layer, okay. And thickness of kth layer is always a positive number, it is always a positive number. So, I can also write this as Qij for the kth layer times Tk, and this goes from 1 to n, Qij bar times Tk, where Tk is thickness of kth layer. Thickness of kth layer. So, the point is that if Qij is positive, and typically Q11, Q22, Q66 they are positive numbers, always positive numbers. So, then in that case A11, A21, A22, A66 they will always be positive. Okay. Same thing is also true for Q12. Q16 could be negative, in that case A16 and A26 could be negative, but in all cases A11, A12, A22 and A6 will always be positive. Okay, they will always be positive because this Tk is always remains positive, and Q11, Q22, Q16, Q11, Q22, Q22, Q12 and Q6s are always positive. So, respective elements in the A matrix are always positive. This is one thing. Next, look at Bij. So, in case of Bij, this is equal to K1 to n Qij bar for the kth layer times hk square by 2 minus hk minus 1 by 2 square. Okay. Now, in this case, this term, it may be positive or it may be negative also. It purely depends on the coordinates. Why? Because each of these terms is a positive number. Hk square is positive, hk minus 1 square is a positive. But if hk minus 1's absolute value is much larger than that for hk, then this can be negative, it can be negative. So, the point is that because of this thing, this term in parenthesis, this can be either positive or negative. So, then what that means is that any term of Bij can be negative, because consider Q11, B11 will depend on Q11, Q11 is always positive, but if the terms in the parenthesis are negative, then it can be negative. And finally, we look at Dij. So, Dij is k is equal to 1 to n Qij for the kth, of course, there is a bar times hk cube by 3 minus hk cube minus 1 by 3. Okay. Now, this number is always positive. Why is it always positive? Because hk's value, because hk is always more than hk minus 1. Okay. It is always more than hk minus 1. So, when I take the cube, the difference will always be positive. The same reason is, for the same reason, hk minus 1 is always positive. Okay. So, this is always positive. So, for that reason, and because Q11 bar, Q12 bar, Q66 bar and Q22 bar are always positive, we can also say that D11, D22, D66 and D12 are always positive. D16 and D26 can be negative, because depending on the value of theta, I can have negative values for those terms also. So, the point is that these terms are always positive. Similar terms in the A matrix are also positive, but in terms of, in context of B matrix, any term can be positive or negative, and it is driven by the fact that hk square minus hk minus 1 square can be either positive or negative. So, this is one general observation I wanted to state. Next, look at some more details about this these matrices. So, if we have n and n, these are the vectors. So, this is equal to A, B, B and D, these are sub matrices, epsilon k. So, these are mid plane stresses, mid plane strains and mid plane curvatures. So, we will consider several cases. Case 1, we can have a lamination sequence, we can have a laminate such that, and we will discuss the conditions when that happens maybe later. So, there could be a situation that when B matrix, all the elements in B matrix are 0, all the elements in the B matrix are 0. Then n equals A times epsilon and m equals d times curvatures. Okay. So, what this tells us is that if for a laminate the B matrix is 0, then if I apply only forces on the edge of the plate, if I apply only forces on the edge of the plate, so I am only stretching it, suppose I am not applying any moments, I am not trying to bend and twist it, then it will generate only strains, it will not generate curvatures. And if I apply only moments, if I apply only moments, then I generate only curvatures. Okay. So, what this says is that if the B matrix for a laminate is 0, force resultants generate only mid-plane strains and they do not generate mid-plane curvatures, and moment resultants only generate mid-plane curvatures and they do not generate any mid-plane strains. This is what it means. Okay. This is very important to understand that. In a lot of isotropic materials, the B matrix is not lot, all isotropic materials made up of isotropic systems, this is actually the case, where you have in a lot of systems B matrix is 0, and so extensional forces only generate strains and moments only generate curvatures, they do not generate mid-plane strains and vice versa. So, this is something important to understand. But we can have another case where B matrix is not a 0 matrix, a B matrix is not a 0 matrix, and suppose in this case you have, let us say, a plate and you apply some Nx, you can also apply some Ny, and you can also apply some Nxy. And let us say that you do not apply any moments. So, you say that moment, we do not apply any moments, but then what do the equations tell us? The N matrix is non-zero, right, and in this plate I am applying 0 moments, external moments. So, this is 0. So, this is equal to A, B, B and D. Mid-plane strains, curvatures. So, we want to figure out what kind of strains and curvatures are in this plate. Now, in this case, because the B matrix is not 0, we cannot say for sure that mid-plane curvatures will be non-zero, okay, because when I write two individual sets of equations, what do I get? N equals A epsilon plus B times curvature, and for, because moments are 0, extra moment resultants are 0. So, this is 0 is equal to B times mid-plane strains plus D times mid-plane curvatures. The second equation tells us that for this system curvatures are non-zero, because the sum of B times epsilon plus D times curvatures is 0. So, second equation tells us that curvatures are not 0, and we have to solve all these 6 equations to find curvatures as well as mid-plane strains. So, in this case mid-plane curvatures as well as mid plane strains are non-zero, and this is all happening because of the B matrix. Similarly, we can have another situation where we have no force resultants, but we have only moment resultants, and in this case also we will find that both mid plane curvatures and mid plane strains will exist. So, what this tells us is that it is the B matrix. If it is non-zero, then it generates, even though if we are just stretching, if we are just pulling the plate in a straight direction, even then it will not only expand and contract, but it will also bend, okay? And that is why it is called coupling matrix. That is why it is called coupling matrix, because it couples the mid plane response of the plate to the mid plane curvature of the plate, it couples that, okay. If this coupling matrix is not there, then the response of the plate to N is purely strain, response of plate to M is purely curvature. But if B is non-zero, then it couples and you have a more complicated situation. So, this is the second case. The second, let us look at some more cases. So, there is a third case, okay. Third case, and here we look at the A matrix in detail. So, we assume that we have designed the plate such that its B is 0, we have designed such that its B is 0, and we are loading the plate only in using N. So, the plate is experiencing Nx, Ny and maybe also Nxy. Okay. So, if B is 0, then the plate will not have any mid plane curvatures, because the bending, the coupling matrix is 0. But then let us look at the equations. So, the equation will be Nx, Ny, Nxy, and that equals epsilon x naught, epsilon y naught, gamma xy naught, and here it will be A11, A12, A16, A22, A26 and A66, A12, A16, A26. Okay. Now, consider the case that we are applying only Nx in the on the plate. Suppose I apply only Nx on the plate. So, if I apply only Nx on the plate, then Ny and Nxy is 0. Okay. If A16 and A26 terms are not 0, then even though I am pulling the plate in the straight direction only in extensional mode, the plate will also develop a shear strain, because A16 and A26 are not 0. Okay. So, A16 and A26 couple extension and shear strains. If A16 was 0 and A26 was 0, then if I pull it, it will only exhibit stretching and Poisson contraction, but if A16 and A26 are not 0, and if I pull it, it will also generate shear strain. Similarly, if I applied only shear stress, NXY, suppose I applied only NXY, if I applied only NXY, and if A16 and A26 are not 0, then these terms, because they appear in the matrix here, they again couple epsilon x, epsilon y and gamma xy. So, even though I am applying pure shear forces on the plate, it is not only experiencing shear strains, but it is also getting stretched and compressed. Okay. So, that is why A16 and A26 are extensional shear coupling coefficients. They couple the shear response and the extensional response, okay. And if they are 0, then the plate, if it experiences purely tensional strain, then it has only extensional strains. If it experiences purely shear stresses, then it exhibits only shear stresses. Now, of course, this is in the context that B matrix is 0, okay. And we look at a fourth case. We look at a fourth case. So, again, for simplification purposes, we still assume that B is equal to 0, okay, and I want to see the bending response of the plate. So, I am interested in seeing the bending response of the plate. So, what do I see? So, in that, when B matrix is 0, then Mx, My, Mxy equals D11, D12, D16, D12, D22, D26, D16, D26, D66. This is Kx, Ky and Kxy. Okay. So, if B matrix is 0, then if I am applying only moments on the system, then these are the equations. If n is 0, then the first 3 equations are irrelevant, and if because only moments are being applied, moment resultants are being applied. Again, we should understand what are Kx, Ky and Kxy. So, what I will do is, I will again show you this book, and suppose this is the x axis, suppose this is the x axis, this is the y axis, and downwards is the z axis. If I bend the book like this, then the plate or the book is exhibiting purely Kx, it is exhibiting purely Kx, curvature in the x direction. It does not have curvature in the y direction when I bend it like this, because when you look at it, it is still straight. So, it is not having any curvature in the y direction. If I bend it like this, then it is having purely curvature in the y direction. So, if I bend it like this, it is having pure Ky. If I bend it like this, it has pure Kx. Ky is 0. If I bend it like this, it is having pure Ky. Kx is 0. And then there is something called Kxy. And what is that? So, this is bending, this is also bending, but then I can also twist it like this. In this case, it is having curvature in this direction also, it is having curvature in that direction also, okay. It is having curvature, and it is also a cross component. So, okay. So, you can have a plate which has curvature in this direction, that direction, and also a cross component. So, W, the slope is changing, the W, del W, second derivative of W with respect to x and y is non-zero, okay. So, that is called twisting, that is called twisting. So, if I am trying to twist it or something like this, so that is the twisting thing. So, this is a bending curvature. this is a bending curvature and this is a twisting curvature. This is a twisting curvature. Now, consider a situation where I apply only mx and I do not apply my and mxy. So, my and mxy are 0. In that case, if these terms are non-zero, d16 and d26, then pure bending moments so mx is a purely bending moment, they generate twisting curvatures as well. Okay, because d16 and d26 is not 0. Similarly, if I apply a pure twisting moment, so what is a twisting moment? mxy. mxy is a pure twisting, is a twisting moment because I am trying to twist it. So, pure twisting moments these guys, they generate bending moments as well. Okay, because of if d16 and d26 are not 0. So, this happens when d16 is not 0 or d26 is not 0. Okay. And typically we do not want our structure to twist because it then tries to shear off easily. So, that is why these terms d16 and d26 couple the bending and twisting response of the plate, and that is why d16, d26 they are called bending twisting coupling coefficients. Okay. So, we have discussed 4 cases. The first case is when B is 0, and if B is 0, then the coupling between the bending response and the midplane strain response, extensional response and the bending response, it gets eliminated. That is why it is known as coupling matrix. The second, so that was about case 1 and case 2. Then we looked at the case when A16 and A26 are not 0, and in this case the extension and the shear strains, they get coupled. That is why A16 and A26 are known as extensional shear coupling coefficients. In the last case is when D16 and D26 are not 0, then bending and twisting response of the plate, they get coupled. So, that is why it is known as bending twisting coupling coefficient. So, this concludes our discussion. Tomorrow we will have another discussion on lamination sequence and how lamination sequence is written using standard lamination code. So, that is what we plan to do tomorrow. Until then, have a great time. Thank you.